which was the most interesting for you when you found it? Like,
The most interesting issues that we found, or the most issues that our tool found, were which all had over 300,000 active installations at the time of fuzzing.
oh,
And
wow.
pass it to the one endpoint, a path with a lot of dot slashes to any file on the server, and would read out the first line of the content.
How do you think Fuzz or your tool works with false positives?
We actually decided and found out that you could use the tool also for debugging purposes. Or we assumed that the developer made a mistake and there was a query which didn't work.
Okay.
So, yeah, we kind of also developed a debugging tool for that.
So you have the fuzzing tool, open source fuzzing tool that Sebastian and team have released. How can they make best use of it? Like, where are the places that they can use it?
So yeah, our fuzz tool is actually open source and we publish it on GitHub. You can just Google my name and fuzz and you should be able to find it.
Hi and welcome everyone to this episode of Breakpoint. We have with us today Sebastian Neef. In NullCon, he is talking about finding 0 days in PHP apps with coverage guided fuzzing. He is doing his doctorate at Technical University of Berlin at the Chair for Security in Telecommunications. Welcome to Breakpoint, Sebastian.
Thank you for having us.
How are you liking the conference?
Oh, I'm liking it so much. Like, really nice people, a lot of cool presentations. I really like the weather here in Goa. Like in Berlin, it's super cold. Now it's here super warm. It's just like vacation. I really like to be here.
Okay, so your topic here in NullCon was quite interesting. But before we dive into fuzzing, I would like to have for our audience, would you tell them maybe briefly what's the difference between fuzzing and pen testing? Because many of us in the security industry know about pen testing, but fewer of us know about fuzzing.
I think fuzzing is one of the methodologies that you can use for pen testing. So pen testing usually is just finding vulnerabilities or flaws in existing systems and trying to get into the systems and maybe tell the customers about the vulnerabilities if you do an assessment. And for that, you usually use different tools. For example, Nmap, Metasploit, maybe Burp Suite, or some other tools to find those vulnerabilities. And fuzzing is one technique that can be used to identify vulnerabilities in different software, for example, in PHP applications, for what I did with my tool.
So PHP as a language has been very dynamic, and over the years what we have seen is because it has been used so often, there are differences in new libraries coming up, the framework is changing, of course the threats are also changing in PHP, there are new attacks every time. What were your challenges when you were trying to find those 0 days using these fuzzing techniques? So fuzzing PHP would be different from fuzzing other languages. So what were your challenges?
All right, so basically there were 4 different challenges because the fuzzer that I built uses coverage guided fuzzing, and that is a little bit different from the classic black box fuzzing that, for example, Burp Suite and other tools use. So what were the different challenges? Mainly the first one is how to discover endpoints to fuzz. So how do we know which endpoint does a specific web application have and what are the parameters of these endpoints? Then the input mutation is the next challenge. How can we change the values of the parameters so we can trigger vulnerabilities in the web application? Then we have to somehow find ways to get the information from the server side about the triggered vulnerabilities to the fuzzer so we can actually detect them. And then also how many vulnerability classes can we support and implement. So if you want, I can dive a bit deeper into the...
Maybe you can take up one of these and talk about.
So the most interesting thing in the challenges was the instrumentation, because compared to black box fuzzing, we just send a predefined set of payloads to the web application and then maybe uses some kinds of specific SQL injection payload or cross-site scripting payload. It will not have the insights from the web application whether that actually triggered the vulnerability or not. So with our coverage-guided instrumentation, we monitor the functions that are executed on the server to get that information. Was there an exception in the MySQL server? Did we actually manage to insert a cross-site scripting payload? And this is called coverage-guided fuzzing. So what we had to do with that was to instrument the different PHP functions. There are some approaches that try to instrument the whole PHP interpreter, but this is quite complex. You would have to change the C-level code of the interpreter, recompile it, And this is super complex and didn't really work for us. So we
Okay.
wanted to find a high-level solution in order to actually make it easier to use for all the developers and maybe people who want to find vulnerabilities for either offense or defensive purposes. And for that, we use 3 open source extensions. So these are freely available. You can just install them into your PHP environment and then use it to hook into the native and non-native PHP functions. So for example, file get contents is one function that would read a file on the PHP server, and we can hook into that and then notice if, for example, a path reversal attack would be happening or not.
Or not. Okay.
And then we can use that in the fuzzer to say, hey, this mutation, this input triggered the path reversal issue in this file get context function.
Okay, that's great. You also mentioned in your abstract, and I was looking at it, there were quite a few, at least 7 classes of vulnerabilities that you found. Which was the most interesting for you when you found it, like, or completely unexpected when you were trying that out?
So we implement 7 different vulnerability classes, ranging from SQL injection over command execution to path reversal and cross-site scripting, open redirection, and some others. So I think the most interesting issues that we found, or the most issues that our tool found, were path reversal or arbitrary file access problems.
Okay.
And yeah, I could dive into one example. So we actually fuzzed WordPress plugins with that. So the top 115 plugins, and which all had over 300,000 active installations at the time of fuzzing. And we fuzzed them with our approach, and we found that there were, I believe, 16 path reversal or arbitrary file read issues, from which in the end 2 were valid vulnerabilities, which could be exploited against multi-site installations of WordPress to read any file on the server.
Okay, and this was all arbitrary, like in the sense were you able to find anything crucial on the installed server? I think you might be working on a sample setup.
Yeah, correct. So we fuzzed these plugin, and then we manually reviewed the findings of the fuzz tool, and in the end we identified, I think, the one plugin was SO Widgets Bundle, which has closely to 500,000 installations.
Oh,
and
wow.
You could pass it to the one endpoint, a pass with a lot of dot slashes to any file on the server, and would read out the first line of the content.
Okay.
Yeah.
Including our favorite files,
Yes.
password and
Yes.
others. Okay, great. Okay, so that's something for the researchers and also the listeners to keep in mind. Lastly, I had just a couple of other things to talk about. One is that we have been hearing a lot about false positives. So just like the traditional black box fuzzers you're talking about, and the tool sets that we have, they come up with a lot of false positives as well. How do you think Fuzz or your tool works with false positives?
So at the beginning, we also had quite a bit of false positives because we monitor every critical function that might be exploitable, and the fuzzer would report any error. So we actually decided and found out that you could use the tool also for debugging purposes. So while fuzzing these WordPress plugins, we noticed that there were some SQL queries that did not work, that raised an exception in the application, but where there was no fuzz input actually in the query. So the developer, or we assume that the developer made a mistake and there was a query which didn't work. So yeah, we kind of also developed a debugging tool for that. But in order to actually find vulnerabilities, we did a slight change to our code base. So we decided to implement another parameter-based detection algorithm. So the fuzzer will check whether the parameter that it has changed is also in the exception message or in the arguments passed to the function in which the exception or the error happened. So with that, we had a bit higher confidence in whether that was a vulnerability or not. So we could reduce the false positives, although a fuzzer just generates random things, sends it to the server, and it might always find some false positives. So we cannot eliminate that entirely, but we can reduce the chances of having false positives.
Okay. One more thing which I was thinking of is you have talked about 7 classes of vulnerabilities. Are there others? Like, what's your plan in future to look for more classes of vulnerabilities or a specific kind, or completely shift from PHP to something else?
Good question. That was a question I received a lot also from the other people at NICON today and also yesterday. So yes, there are plans to extend this to other programming languages. I currently apply for funding to hire some students So we can actually support, for example, Java or Ruby or some other programming languages. And also for the vulnerability classes, I would like to extend it to, for example, server-side request forgery, template injection. What else comes to mind? Any vulnerability class that can be mapped to specific dangerous functions in the PHP environment could, in theory, be implemented in Fuzz. And since Fuzz is quite a modular system, one could simply extend it easily. So you just implement another vulnerability detection class or another mutation class, and then you should be able to detect a different class of vulnerabilities. So yeah, that's definitely on the roadmap for us to do.
Okay, that sounds interesting. For the listeners who are listening to us, there are many of them who are in security teams and they're software engineers. What would be your one message to them, given that you've found so many classes of vulnerabilities and also actual issues in the plugins? What is the one or two things that they can do while they're building the applications when they're using PHP to actually avoid these issues?
I don't think there's only one thing I could say, because there's many things one could say.
Any patterns that you see which, or 2 or 3 issues which you think they can definitely, avoid?
But I think one important thing would be to be open to security reports, also to read the documentation. One issue that we noticed with the 2 vulnerabilities that we found, that it relies on the functionality of one specific function of the WordPress API, which might not be completely understandable because it's called isAdmin, and some people might assume isAdmin would check whether the user is an administrator or not. But if you read the documentation, it says that this function does not actually check whether the user is an administrator, it just checks whether the URL is part of a specific administrative interface. So for developers to develop more secure applications, read the documentation, try not to have assumptions about what the code does or what the function does, and be open to security reports. Sometimes developers might feel offended by security reports, but in reality, we just want to help. We want to help you make secure code, and if you receive a security report, be as all the different WordPress plugin developers, which were very thankful for the report, and they quickly implemented the fix. So work with us, we work with you, and in the end, we have good, proper, secure software.
Well said. On that note, the last thing that I had for you was Fuzz. So you have the fuzzing tool, open source fuzzing tool that Sebastian and team have released for the researchers. How can they make best use of it? Like, where are the places that they can use it? What's the best way to use this?
So yeah, our Fuzz tool is actually open source. So my opinion is public money, since I'm funded by the public in my university. The code should also be public and usable by others. That's why it's so modular. And we publish it on GitHub. You can just Google my name and Fuzz, and you should be able to find it. And yeah, if you would like to use it, you can simply set it up. It's a Dockerized environment. You can use Dockers to start it, the different components, and also extend it freely. Like if you are in a company that has different PHP requirements to run, you could adjust the configuration of our environment where you place your source code to fuzz your own application. That should be doable and is also encouraged by me and others.
Okay. Thanks a lot. Thanks a lot for joining us today at Breakpoint.
Thank you for having me.
Okay. Thanks everyone for joining us today. We'll see you all in the next episode. Until then, bye-bye.
Bye.